Hello bachcho, today we are starting a brand new chapter, Unit 7, Alternating Current. Now, I know many students find this chapter a little tricky, but trust me, don't worry at all. We are going to break it down so simply that you'll never forget it. And yes, every single point will be 100% exam safe. So, let's begin.
So let's start with a simple question, something you've probably noticed in your everyday life. You've definitely heard it, right? That sound from a big transformer on the street, or maybe even from some of your phone chargers at home. What is causing that sound? Well, the answer is hidden inside the very nature of alternating current. By the end of this session, you'll know exactly what that secret is. Okay, first things first, let's build a very simple mental picture. Forget all the complex maths and formulas for just a moment, and let's just imagine what is actually happening inside the wires. Think of direct current, or DC, which you get from a battery. It's like a river, you know? The water flows steadily in just one direction. The water molecules themselves move from one place to another. But AC is completely different. Imagine water trapped inside a closed pipe. Now, if you shake the pipe, the water will just slosh back and forth, right? The water molecules just jiggle around their position. They don't actually travel all the way down the pipe. That's AC. So this brings us to the most important point. The core idea. In DC, the electrons, the charges, are themselves transported from one end to the other. But in AC, the electrons just oscillate, they jiggle, and they pass energy to their neighbors, like a wave. So it's the energy that travels, not the electrons themselves over long distances. This is the fundamental difference, Bacho. Please remember this. All right, now that we have a feel for it, a good mental picture, let's look at the official exam-safe definition. This is straight from your NCERT textbook. This is the exact wording you should remember for your exams. The most important phrase here is varies like a sine function with time. What does that mean? It means the voltage isn't constant, it goes up, it goes down, smoothly, just like a sine wave graph. And naturally, the current that this changing voltage drives, well, that's what we call alternating current. And this brings us to the famous formula. Now, don't be scared of it, it's actually very simple. The small v here is the instantaneous voltage, basically the voltage at any given moment in time. Vm is the peak voltage, the maximum value it can ever reach. It's the amplitude of the wave. And this symbol, omega or omega, is the angular frequency. It's just a number that tells us how fast the voltage is oscillating back and forth. Simple. So, how is this AC even made? Let's build it up step by step. First, you know DC, right? From a battery, it gives a constant voltage, a straight line on a graph. Now just imagine a source where the voltage isn't constant but goes up and down smoothly, like that sine wave. What does good old Ohm's law tell us? It says I equals V of R. So if the voltage is changing like a sine wave, the current has no choice but to follow the exact same sine wave pattern. And the rate of this oscillation, that's its frequency. In India, our entire power grid, every plug point in your house, operates at a fixed frequency of 50 Hertz. That means 50 full cycles every single second.
Chalo, let's do a tiny example to make this crystal clear. Suppose in your exam, you're given the equation V of t equals 50 sine 100 pi t. What do? Just compare it to our standard formula. V equals V naught sine omega t. Just by looking, you can see that the peak voltage V naught is 50 volts. Easy. And the angular frequency omega is 100 pi. We also know the formula that omega equals 2 pi f. So, to find the frequency f, we just do 100 pi divided by 2 pi. The pi cancels out, 100 by 2 is 50 Hertz. See? Bilkul simple. Okay, now this next part is very, very important. Let's talk about some silent killers. These are common mistakes that students often make in exams. If you can just avoid these, you will be way ahead of everyone else. The first wrong idea is that in AC, electrons flow backwards. No, bilkul nahi. Remember our water pipe analogy? The electrons just oscillate around a fixed position. There is no net movement from one end to the other. A simple way to remember this is AC is oscillation, not reversal. The second huge mistake is confusing RMS voltage with average voltage. Think about it. For a full sine wave, the positive half and the negative half are perfectly symmetrical. So if you take the simple average, you get 0. It's useless. That's why we use something called RMS, which stands for root mean square. Just think of it as the effective value. It's the equivalent DC voltage that would give you the same amount of power or heat. And the formula is super simple. VRMS is just the peak voltage divided by the square root of 2.
And the third common mistake is thinking that AC frequency changes from place to place. No, the frequency for an entire country's power grid is fixed and very stable. For us in India, it is always 50 Hz. The voltage might fluctuate a little bit, sometimes it's 220 volts, sometimes 230 volts, but the frequency, that is rock solid at 50 Hz.
So, here's a fantastic way to remember this forever. Just think. Frequency is the grid's DNA. It is a fixed, constant signature for the entire system. 50 Hz for India, always. Okay, so let's quickly connect this new idea to what we've already learned in previous chapters, and then we'll summarize everything. You see, this chapter on AC isn't just some new random topic. It's directly connected to Faraday's law from Unit 6, electromagnetic induction. Remember, when a coil rotates in a magnetic field, the induced voltage naturally varies like a sine wave. This is exactly how AC is generated in all our giant power plants. It all connects. So, to summarize everything we've learned today, 1. AC is current that oscillates following a sine wave. 2. It transfers energy, not charge, over long distances. 3. The voltage is described by the formula V of t equals Vm sine of omega t. 4. In India, the standard grid frequency is fixed at 50 Hz. And finally, AC is used all over the world because transformers can easily step up or step down its voltage, which is super useful. And that rapid 50 times per second change in the magnetic fields inside a transformer, that's what causes a physical vibration, which is the humming sound we talked about right at the beginning. See, it all comes full circle. So now we have a solid foundation of what AC is. But trust me, this is just the beginning. The real fun, the real physics starts when we apply this alternating voltage to different circuit components. So the question to think about for next time is, what happens when this sloshing AC current meets a simple, humble resistor? We'll explore that in our very next explainer.